In this video, I shall explain how to draw simple horizontal line in Python using wxPython. Later, we shall see how to rotate a line in using Python programming language. I shall also explain how to move a line vertically down. I'll be using PyCharm Community Editor to develop the Python code and wxPython for generating the graphic. Wx is a wrapper which interacts with C++ library to generate the graphics using Python programming language. Now let us start coding with Python. Before starting to code, we need to install two important libraries. One is wxPython and the other one is NumPy. These can be installed using pip command in the command prompt or the way which I follow. Go to File, Set Settings. In Settings, go to Python interpreter. In this you can see the little plus sign here. You can click the plus sign. Before clicking the plus sign, you need to add the interpreter, Python interpreter. After this, you can click the little this plus sign and you can search for the packages wxPython, and you can install the packages. I have already installed these packages. So after installing these packages, we shall continue with the code. Now let us import the installed packages. Import wxPython is imported as wx, and then import NumPy. After importing these packages, let us create an application object by the following command. Application object in wxPython is created by this command. This will create application object. After creating the application object, we need to draw any graphic. We need a frame on the screen. So let us create the frame first. Frame wx.frame. I shall explain these parameters. None, -1, and the third parameter is the name of the frame. Here the parameter none means this is the parent class and there is no other parent for this class. -1 tells Python interpreter to give any random ID. Generally the IDs given by the computer automatically are negative and the IDs we give to program are positive. The parameter line, as I said before, is the name of the frame. Now the frame which is created will have a gray background. Let us set this background to white. This can be set by frame.set background color and we will set it to white. After setting the background color, let us fix the frame to center of the screen. This can be done by frame.center. After this, after creating a frame, it has to be shown on the screen. This can be done by frame.show. Now let's maximize this the frame.maximize. This will create a frame for us, and on this frame we shall draw our graphic. I have maximized my font for better clarity. Now if we run the small piece of code, we will see what is the output. A window just appears and dies quickly. So we need to create an endless cycle to show the frame continuously on the screen. This can be done by app.mainLoop. This is an endless cycle which catches the events and processes the events. So now if I run my code, the frame will be visible. Now you can maximize the frame, minimize the frame, and you can close the frame as well. Now let us draw our line on this frame. To draw the line, we use the DrawLine command. But before drawing the graphic, we need to create a device context object. This device context represents number of devices such as printer, screen, etc. There are number of device contexts in wxPython, which I shall cover in my next video. I use here client DC device context. wx.client.dc is used to draw on the client area of the window, which is a frame which we created just now. So let us get the device context first. This can be obtained by device context. DC is wx dot. We will use the client DC and the client area on which we are drawing a graphic. This will generate a client DC. We can obtain the size of the client area by the following command. Size is dc dot get size. This will give the size of the frame. With the size of the frame info, we can extract the coordinates of the center of the screen. This command returns a tuple. So now let us draw the line first. The syntax for drawing a line is, line command is self x1 y1 x2 y2. Here x1 y1 are the coordinates of point 1 and x2 y2 are the coordinates of point 2. So this DrawLine command simply draws the line from point 1 to point 2. Here we shall draw a horizontal line. So here we shall maintain the y coordinates same, means y1 is equal to y2. To obtain the coordinates of center of the screen with the size information, we can obtain like this. Since this is tuple, size of 0 by 2, this will give the center of the screen, and YO size of 1 by 2. This will give me the y coordinate at the center of the screen. As you are aware, the coordinate axis in Python is the left top corner, x-axis is towards the right, and positive y towards the down. Now let us draw the line DC dot DrawLine. The first point is XO, YO. These are the coordinates of the first point, and the second point, since we are drawing the horizontal line, we'll draw a length of 400 units. I'm varying only the x coordinate and keeping the y coordinate same for the second point. Now this will draw me a horizontal line of 400 units from the center of the screen. Now if I want to draw a second line below this first line, it can be drawn by using the same command. Now I will draw some 100 units below this line. The length of the line remains the same 400 units I will be drawing. Now if I run this code which is written, I should be able to see two lines, one below the other. Now let us see. I run this code. Now you can see the screen in frame, two lines, one below the other, of the same equal length and 100 units apart. Like this we can draw as many lines as we want on the screen based on our requirement. Now let us go to the second phase of the video where we want to rotate this line. This is a bit tricky, which I'll be explaining now. I could not find any rotate method in wxPython package, so I figured out a workaround to rotate the line. Before going through the logic of the program, I should explain one more function, which is setPen. This method is used to draw the line with the color we want. So what I shall do here is draw a line with the same color, pause for some seconds, later draw the same line with white color. After this, I will not give any delay. This will be in a loop which will give us the animation of rotating a line. So let us code this logic. Let's delete this line first. One line is sufficient for this demo. So let us start this code. So I will begin with the for loop. Since we are rotating the line in a circle, I will take the help of trigonometric functions where any point on the circle can be given in terms of cos and sine. As we know, the total angle in a circle is 360 degrees or 2 pi. So let us divide this angle 2 pi into 100 division to rotate our lobe. So to do this, we require for I in np dot linspace. Here, if you notice here, np is a numpy package, so we need to import numpy. Once this package is imported, we can access this command linspace 0 2 pi math.py, and then how many we will divide into 100 divisions. Math package is a default package, but it needs to be imported in Python. Import math. Now let us set the pen to some color. I'll make it red color. DC is the device context in which way we are setting the pen using wx.pen, and the color of the pen which it will draw the line is red color. Once this is set, now let us draw the line with this color, dc.drawLine. Here, before drawing the line, let us rotate this line some 100 units below the first line. For this, what shall we do is YO. We shall make it YO plus 200. Okay. Once I made this, now I can draw the line dc.drawLine. First point is XO, second point is YO, and then XO plus the radius of the line I will take as 200 into math dot cosine of, as I told before, the point on the circle can be represented in terms of sine and cos with the radius, where the radius vector is 200 units in our code, and this is the second point, YO plus 200 into math dot sine of I. Here XO YO is the first point, and XO plus 100 YO plus and this is the second point. My mistake, it's YO. I typed it as 0. Now after this, I will give a delay of some 0.2 seconds, and then I will draw the same line, and now I will set the pen to white color, wx.pen, and this will be white color. Now I will draw the same line again. With the white color. Here it is showing an error because time is also a default package in Python, but it needs to be imported. Let's import the time package. Import time. Once this is imported, now this error is not there. Not there. Now let's see how the animation looks like. Now you can see the line here rotating in a circle. This is the clockwise direction. If you want to give a rotating anti-clockwise direction, just you have to give a negative sign. Now you can see how the line is rotating about in a circle. Now let's increase the speed of rotation by reducing the sleep command. This sleep plays a crucial load which will give the taste of animation. Now here actually we are not erasing the line. We are drawing the line with a white color, and hence we are not able to see the line. So basically it is drawing I will run the animation once again. It is drawing multiple lines, but on red line is visible, white line is not visible. This is how we rotate a line in Python. Now let us see how we can show the animation of a following line. The logic is similar to rotating the line, but here there is a catch. Let us see the code. So we will try to draw in the left side of the screen because the space is totally empty. For this, I will shift my x coordinate by some 500 units towards the left, and y coordinates I'll shift some 300 units to the top. Now let's start the loop for I in range 1 and 50. Here the idea is I will be varying the y coordinate so that we will get, and I will explain the code. In this I will be varying the y coordinate. So let us set we'll be drawing a horizontal line. The horizontal line will be falling on the screen. To draw the horizontal line, we need to maintain the same y coordinate, but here there is a catch which I shall explain. Now I'll set the pen. Set the pen first. Wx dot pen. I'll draw with some violet color. Violet. And then let me draw the line. Draw line. First point. And then second point, we'll maintain the length of the line at some 500 units, and then the y coordinates should be the same. But here there is a catch which I shall explain. We need to vary the y coordinate so that we'll get a feel of falling. The horizontal line is falling vertically on the screen. So I will write here y I into 10, and here also y plus I into 10. Here we need to here they should not be, the y coordinates of both the points should not be the same. I really did not understand why it is happening in the loop, which I'm trying to find out the answer, which I'll show you in my demo also. If I maintain the same y coordinates same, what will happen? So for this reason, we need to subtract just one, plus or add or subtract just one unit, means we should show that they are not the same. Now the logic is same. We will give the sleep for some seconds, and then again we'll set the pen to some white color. I will copy and paste this piece of code here. I'll make it white. Now let us run this code and see the output. After the line is rotating, we should see a horizontal line falling. Now you can see the horizontal line which is falling, but the y coordinate, this point and this point are not the same. Suppose if I maintain the same y coordinates, we will see what will happen. Now I maintain the same y coordinates of point 1 and point 2, which will actually draw the horizontal line on the screen. Now if I run this piece of code, you can see after this line is rotating, we will not see any animation, any horizontal line falling vertically. So for this reason, we need to give at least a difference of at least 1 unit, plus or minus 1 unit. Now I'll give plus 1. Last time I gave minus 1. Now I'll give some plus 1, and I will run this code again. Now you can see after this line is rotating, we can see a horizontal line falling down. This completes my lecture on this. This completes my explanation of the line falling, line rotating, and drawing a simple horizontal line. Here I want to tell one more point. I use the client DC device context. I'll show you what is the disadvantage of this. What is the disadvantage of this device context? Now if I run this, now I got one horizontal line, and a line rotating, and then a falling line. Suppose if I minimize this window and maximize it again, notice what happens to this horizontal black line. I'm minimizing it, and again if I'm maximizing it, the line disappears. This is a disadvantage of client DC. So whenever the window is maximum, frame is maximum minimized, the graphic again needs to be redrawn. I will explain in my next video how to overcome this problem To overcome this problem, we will use the Paint DC device context. This I will cover in my next video. Thanks for watching.